Yeah, we are live. Hi, good evening, everyone. Welcome to the part two of building full stack serverless applications with Gunnar. I hope you enjoyed the first session. And if you are here for more of that, you are at the right place at the right time, I would say. I won't take a lot of time this time. We already know who Gunnar is and what magic he can do with serverless. So I will just hand it over to him and let him do his magic. Over to you, Gunnar.
All right, thank you very much. Hi, everyone, and thanks for having me again. I guess when my session runs over so much, like the last one did, they have to have me back once again. So this time for part two, we're going to more or less only be building stuff. And let's see how it goes. Hopefully, in the end, we'll have a working serverless application with both front end and back end. So today, only 4 slides, I think. So this is the agenda for today. First off, we'll just look at what we're going to build, and then we're going to build it. So what we're going to build today. And just before we jump into everything, if you have questions when both in the beginning, when I'm talking about what to build, and while building, just keep the questions coming. Anurag and Torshal will keep an eye on the chat and just jump in with the questions as they arrive. All right, so what we're going to build. Well, of course, it's going to be a full stack application, so it's going to have both a back end and the front end. The back end, we're going to look at the architecture shortly, but the back end will probably be the one where we focus mostly on. And then when we've built different parts in the back end, we'll start off with just a template front end application and try to add the different components there. So we're going to have authentication in the application, and we're going to do that by using Auth0. So we're going to connect what we're building to Auth0 for authentication. We're going to have one part of the application where we're storing items. So we'll be able to store an item within our application. Another part is, of course, to then get items. To be able to retrieve the items that we have stored. We'll be able to list different items. And we'll also have functionality for rating items so that we're able to rate, or other people are able to rate the items that we have added. And the application in itself, well, look at it as a framework for perhaps building something else. So we'll have these basic functionality within it. And then based around that, I think we can create more or less any type of application that revolves around storing items and then perhaps rating items as well. So look at this as a framework, more or less. Yeah, we will also have the possibility to change the ratings that we've added. So based upon that, the basic architecture, well, that looks more or less like perhaps the most basic of serverless applications, the traditional web service, where the client makes a request to an Amazon API gateway, which in turn invokes an AWS Lambda function, and then either stores or retrieves data within DynamoDB, returns that data to AWS Lambda, returns it to Amazon API Gateway, and then back to the client. So really a traditional synchronous application that way. And we should be able to solve more or less all of the, or maybe all of the functionality that I listed before using this. But to do that perhaps wouldn't be the most fun session either, to do it this way. You've probably already seen a lot of sessions where people build this or samples. So I want to change it up a bit and do it a bit different. So instead, I want to build a decoupled application, one that is more scalable. Because, well, we know that serverless is scalable, it has high availability and so on, but there might be reasons for making an application even more scalable so that it's able to handle load even better. And by decoupling the application, we're able to go from a synchronous operation to asynchronous operations. So let's look at the architecture that we are going to build instead. We have a client. The client, in this case, is storing an item. So it makes a post to Amazon API Gateway, and we will be using HTTP APIs, the new flavor of Amazon API Gateway. That in turn invokes a Lambda function to handle the data that is posted to Amazon API Gateway. But instead of, as in the previous example, that we're storing that data directly into DynamoDB, instead, we're going to use SQS, Simple Queue Service. So we're storing the item that is posted into a queue instead. So what happens then is, well, as soon as Lambda has been able to store the item, it gets a response that says that the item has been stored, and that is what the client then receives. Based on that, then, we'll have a Lambda function that picks up data or messages that are in the queue and processes those messages and then stores them in DynamoDB. And by doing this, we're able to change from a synchronous behavior to an asynchronous behavior, and we're able to decouple the application. So even though, let's say that we have a big amount of items that are going into the system, well, that won't then put pressure on the downstream services, in this case, DynamoDB. Or say, for instance, that our Lambda function is doing more transformation or doing things with the data that is posted. Well, by having them being stored in a queue first, it means that we're able to input a high number of items that are then processed as we're able to keep up with data. So that's an easy way of doing a more decoupled architecture. And then instead, when the client gets data, well, that works in the same way as before. We're doing a GET request to HTTP API, the Lambda function invokes and then gets data from DynamoDB. And the same thing when we're doing the rating of items. So post request to API Gateway, invokes Lambda, stores in SQS queue, and then we have a Lambda that processes this data as well when it's possible. And then stores that in a separate DynamoDB table in this case. And when we want to get the ratings, well, it works in the same way. So we're fetching those from DynamoDB. But then instead of having this data in two separate tables in this way, when we have an item and we want to know how that item is rated, instead of doing separate lookups to the separate ratings table, we're instead going to use a Lambda function to get this data from DynamoDB and then update it in the items table instead. So we're aggregating that data. So then we're able to do it just by one lookup in the first items DynamoDB table. So this is basic architecture of it, what we're going to build tonight or today, depending on where you are. And that's what we're going to do right now. So we're going to start off from scratch with this. Don't really have any project to start off with. So we're going to start from scratch. And while doing this, I'm going to try to both look at my notes and some coding and so on. So bear with me if I lose what I'm doing for a short while. Hey,
yeah. Let's take a moment. We have a couple of questions.
Yeah.
So the first question here is, could you please shed some light over what is the difference between workflow of building backend with Express API roots and Lambda mindset?
Well, the difference in mindset?
Yep, that's what the question is.
Yeah, well, I'd say that when you're using Express-based, those are usually fewer number of Lambda functions. Perhaps you have bigger Lambda functions that does more things. We usually, when we build Lambda based architectures, we want to have smaller Lambdas, the smallest possible Lambda functions that only do one thing. So that each Lambda function just does one thing within the architecture. And my understanding of doing it, well, instead of using Express, perhaps you'd have well, the same amount of functions, but they are all within the same function. I think that's it.
Okay.
So we're breaking it up even to smaller bits, I'd say.
Yeah. Another question is, what is the difference between SAM, then Cloudea.js, if I'm reading it right, serverless framework, or AWS CDK? Which one works well, and which one should opt for?
Yeah, that's. I guess that's the difference. Well, different teams or companies have created them. First off, SAM is from Amazon or AWS. Serverless Framework is a company called Serverless Inc. Cloudea, I'm not sure. It's open source, I guess. And then CDK, that's also Amazon Web Services, but not only for serverless, first off, and it's another way of creating your infrastructure. And which one to use? Well, I guess that depends. I tend to use Serverless Framework for most of my projects, but also SAM. Tonight we'll be using Serverless Framework. Both of them use CloudFormation behind the scenes, and a lot of the things that we do create with the templates is the same syntax as with CloudFormation. But there are small differences with them. One has been that Serverless Framework has had plugin support. That's something that SAM is getting now. So maybe that will change things a bit as well. So it's a matter of taste, which one you want to use. Anything else?
Yeah, one more question. Could you please elaborate the use of Lambda between two DynamoDB table in this architecture?
Yeah, and in this case, I guess it's good that you're here, Anurag, as well, because this is not a single table application. So we have two different DynamoDB tables. The top one in this architecture, that's for the item data, the item that we're storing. The bottom one is for the rating data. So for each person or user that rates something, that is stored in the second table. That data is then aggregated using DynamoDB streams each time something is created, updated, or removed from the ratings table. It invokes a Lambda function that more or less just counts the votes. So it counts how many ratings there are and what value each person has rated the item. And that is then updated into the item that is in the top table in this case. So it's a way of having the data, the ratings data, easily accessible within the same item. But still, it's separate. The functionality is separate, not using the same table in this case.
Yeah, right. Okay, I think that's it for now. We can go ahead.
All right, cool. Just keep your questions coming. Only 15 minutes so far. All right, so first off, bear with me. We'll start from beginning. We'll start with a new project. Just creating a folder. Let's call this items rater. and open that in code. All right, so as I said, we will be using serverless framework for this. We could use SAM, we could use CDK, and so on as well. But in this case, we're going to use serverless framework. I'm just going to hide that one. There we go. All right, I hope the font size is good enough. And then let's just create a backend folder. Within that, create our template file. So this is the template file for our serverless project. Start off with a blank one. So just opening my notes here as well. Sorry about that. All right, so pasting over some data to start off with. Well, calling it items rater, like that. In the template, we're able to limit which framework is needed to be able to do this. That's just boilerplate. Serverless framework has the ability to use other providers than AWS, but in this case, of course, we'll use AWS, and we'll be using Node.js 12 for this. So going back to the architecture, just to see. That didn't go well. Just to see what we're going to create. So we're going to start off from the top of that image. PowerPoint shut down, sorry. And the first part was, if you remember, that we had an API gateway and we had a Lambda function and then we had an SQS queue. So that's what we're going to start off with. Let's see if I can get the... There we go. Like that. So those are the first parts we're going to create now. And this is, as I said, for storing items within our database. So first off, we can start by creating some resources. There we go. And let's start then from the end. First off, we need an SQS queue in this case. And in the template, we have a section for resources. And here we're able to create more or less any type of AWS resources using basically CloudFormation syntax. So in this case, let's call it items queue. And that is going to be of the type, oops. So that's going to be our first queue. And there is more properties or more configuration we can do, but in this case, this is all we need. We're saying to Serverless Framework to create an SQS queue. And it's going to get a name based on the stack that we're working on. All right, so that's the first part. Second part then is that we're going to have a Lambda function, of course. So I'm not going to write the entire function. Instead, I'm going to do a bit of copy pasting there. So this is syntax in the template. Calling it item post, and we're defining what the handler is, and we'll look at that shortly. And then we're able to add environment variables. And in this case, we want to define a variable called queue URL, and then we're referencing the queue that we're creating down here. So when we're invoking our Lambda, we're able to get the correct queue URL that has been created. So that's the first part. The second part is that we want to, of course, have a trigger for our Lambda function. And in this case, the trigger, as I said, is going to be the new HTTP API. And this one, since it's about posting items, we're setting the method to post and giving it a path, in this case, basically item. So we have the basic steps for creating this function now. What I'm going to add more is, since I talked about that we're going to have authentication in this, I'm going to add that straight away so we can see that we have that in place as well. We do that using another property. There we go. An authorizer, and we're referencing what I'm calling service authorizer. We could call this more or less anything, but further up in our template, we then add configuration for this service authorizer, since we're going to use it for multiple Lambda functions. In this case, I'm setting preferences for our HTTP API. That course should be true. And we're adding an authorizer, in this case, the one that I call service authorizer. And we have a few settings that we're going to use. And these settings, they are defined, in this case, using auth0. So we'll look at the settings in auth0 as well. But basically what they say is that the identity source for these requests are in the request header, and a header that's called authorization. We have an issuer URL, and that is, in this case, my URL within auth0 that I've created there. And then we have something that's called an audience, and this is for hooking up the API in auth0. And this could be more or less anything. This is just a default one that's often used. So that's the one I've set now. All right. So what we've done now is add an SQS queue. We've added a function. We've hooked that up to an HTTP API. And we've configured authorization for the HTTP API. The next step, of course, then is to create the actual code for that function. So let's do that. Post JS. And as I said, we're using Node.js in this case. And I'm going to do a bit of copy pasting now. We'll look at the code, what that is. Right, here we go. So this is the code for the post function. We're using the AWS SDK, of course. We're configuring with the correct region. This is an environment that's always there. Then we've added configuration, or we're loading the SQS part of the SDK so that we're able to work against SQS. Because in this case, as I said, we're going to store the item within a queue instead of storing it directly within DynamoDB. Then we have the handler for our function. In this case, there's a bunch of console logs, but first off, it's checking for a body so that it actually contains something, the post that we've made. If it doesn't contain anything, it will create an error and return a 422 to the client. Then we are using data that we receive from HTTP API and the client. In this case, we have information around the authorizer request. And that's something that we're going to use to be able to tell who has created this item. We're just fetching a timestamp from the event, and then we have the actual body. That is the content that we are posting. That might be data from a form, for instance. The process environment, or the environment variable that we created earlier, and that's something that we are able to use now to define which queue we're using. That's what we're doing right here. And then we're using a basic try-catch type handling of this data to be able to try to store the message within SQS. So we're getting the data that we received in the request and then trying to store that within SQS. If it doesn't work, or if it works, then we receive a 200 response back and a message that the item has been saved. If it doesn't work, well, then we'll receive an error code instead, returned to the client. And handling these types of errors, that's something that has to be done on the client side, and how the client handles those, or the front end, basically. But in best case scenario, well, then the item is saved. So that's that function. What we're missing now is one thing. We need to define properties to be able to have the correct permissions to be able to store items within that SQS queue. And using serverless framework, this can be done in two different ways. The default way is to store or set the permissions on a provider basis. That means that we're setting up, it creates a role for all of our Lambda functions, and then all of them will get the same permissions. And in an environment where we have, in this case, 6 or 7 different Lambda functions, that perhaps isn't really good practice, because it means that all Lambda functions will have access to the same SQS queues, the same DynamoDB tables, and so on. And that's not least privilege. And least privilege is what we usually want to have. So the other option is to use, as I said before, Serverless Framework has support for plugins. And we can then use a plugin to be able to do this correctly. And that plugin, we can now install that. There we go. So there's a plugin that's called Serverless IAM roles per function. And that gives us the opportunity to set permissions per function instead. There we go. All right. And then I'll just add that. The end of my template file, just added as a plugin. And now we're able to set permissions per function. And let me copy paste those as well, because we don't want to get those wrong. Right, so we have the items queue. Right, so right now what I'm doing is adding permissions for this Lambda function to, so far, do everything that is related to SQS on the queue that's called the item queue. And we can restrict those further, of course, so that it's only able to create messages or something like that. But so far, let's stick with this. There we go. And now we should be able, if all goes well, we should be able to deploy this first step and then have those created. And I'm just using the SLS, which stands for Serverless Deploy command. I'm setting a stage, calling that dev right now, and using the EU West 1 region. And what Serverless Framework does now when I'm doing this is that it's packaging everything, and it's, there we go, something was wrong, of course. Bad. Right again. YAML indenting. See if it goes better this time. So it's packaging everything. into a zip file, and it's creating a CloudFormation stack, uploading that and running the CloudFormation stack, which then deploys everything that is needed in this case. So what it should deploy now is HTTP API, Lambda function, and an SQS queue, if all goes well. So let's just wait for CloudFormation to finish, and then we'll get an output to see what it's created.
In the meanwhile, we have a small question, Gunnar.
All right.
So Rachit wants to know what should he refer to learn the serverless YAML tags.
Can you take the question one more time?
Yeah. So Rachit says, what can I refer to learn serverless.yaml tags? So I think he's referring to the tags that you're using in the serverless.
Yeah.
Sorry. Yeah.
Yeah, that's a good question. What I'd say is that since a lot of this is basic CloudFormation, so having knowledge of CloudFormation, that's perhaps one good thing, and to know how to use CloudFormation for creating infrastructure. Another part is of course the different frameworks. So SAM has their specific syntax around certain things. Service Framework has their specific syntax around certain things. So depending on which framework you're using, you might need to learn specifics around those. But a good way of doing it, well, that is looking at samples, looking at things that other has built. When creating things, perhaps you're not always starting from scratch. You're reusing other things that you've developed or things that others have developed. And so you're able to look at that, how it is created. So I'd say that's the perhaps best way of doing it. Start off small and add new features and new things to it as you go along.
Yeah, and I think the documentation of serverless.com is also quite extensive where you can get started.
It is. They have really good documentation and a lot of blog posts that explain things more in detail as well.
Yeah. Awesome.
Yeah. So now it has deployed. There was once again a spelling error somewhere. So now the second time it worked. So now it's created the things I mentioned. So we now have an endpoint for our HTTP API, which basically is a random URL and /item, the one that I defined earlier. So to that now, we should be able to actually post items straight away. So to do that, though, we need to use auth0 since we have the authorizers in place. So let's jump there. Try to find a browser. Here we go. All right. So this is auth0, their dashboard. And I'm using the free plan. For this type of applications, there's no need for the bigger plans for auth0, so I can use the free plan. And what I've done basically is to first create an account, of course. Then I've created an application, and that application then gives me the values that I needed before. So I have the domain, it creates a client ID and so on. And then after that, I'm creating an API. And this is the one I've created now, items rater. And there I've set the API audience like this. So the audience was the setting that we had there. So that it's able to link those. Let's go in there. Go to test. So when using auth0, we're able to use different types of third parties for authorization. For instance, Google login. And that means that we're easily able to create a login-based solution that can use existing user accounts, which makes it a bit easier instead of handling all of those ourselves. And what we're going to do now is just test our API. And we're going to use Postman for that. Postman is a great tool when testing APIs. Let's create a new request. Item post. There we go. We're using post as a method. The URL is the one we got from the output in serverless framework. Here we go. Then we need to add the authorization. And we can easily use one of the pre-select options here, the one that's called bearer token. And the actual token, we have that there. And for some reason, it's pre-populated. That's good. And then we go to body, and we select what we're going to post to our API. And what we're posting is JSON. Now I just need to remember. My syntax for this. Just give me a second. Yeah. It was basically item and then content of that. You can talk and write at the same time. All right. So now we should be able to post this. There we go. And the result says that item has been saved. That means that we posted to HTTP API, which invoked a Lambda, which stored in SQS queue. We received a reply back that the item has been saved. So now there should be a message waiting for us in the SQS queue. So let's look at that as well. There we go. Find our queues. Items rater dev items queue. So this is the name of our queue that has been generated from serverless framework. And we can then look inside the queue and see that, yes, we have one message within it. And it contains our body, which was item. This is an item. So cool. Besides that, it's stored, as I showed you, the UID, which is the user ID in this case, and a timestamp. So exactly the way we want it. So that's cool. Now we have the first step done. And jumping back here, we can see that the next step then is to have a Lambda function that picks up messages from the SQS queue and stores those within DynamoDB. So that's our next thing to build. There we go. So next up, let's create the second one. And we're calling that item process. There we go. To be able to do processing of this, we need to add another thing in our infrastructure, and that is the DynamoDB table. And DynamoDB, as with SQS queues, we add those in the serverless framework template. And let me get that data. We'll be using it. This. You can see that. We're adding, I'm doing it in 2 steps now. Sorry about that. There we go. All right. So I'm calling it within the template for items table. It is of the type DynamoDB table. I'm setting the property deletion policy to delete right now, which means that if I delete my stack, it will delete the table and its contents. It also means that if I do major changes to the DynamoDB table, it will also delete the table and create a new one. And that's something to remember when you're working with DynamoDB tables. The other option is to have retain. That means that it won't delete it. So if you're trying to roll back the entire stack, it won't be able to delete the table by itself. You have to do that manually. And that's a way, of course, to preserve the data within the table. So since this is just for dev test, I'm setting it to delete. I'm setting some properties. In this case, we have an attribute for hash that's called PK. We have another one that's called created, a number. We've set it to pay per request, so we don't have to provision any specific throughput. So it's pay for use, basically. So that's all we need to be able to create our DynamoDB table. We're just creating the first table right now. I will also add a secondary index. Let's see. I'm not sure if we're going to use that right now, but I'll add it straight away anyway. And the global secondary index, of course, is a way for us to be able to do queries and so on using another index than the default index of our DynamoDB table. All right, so by adding that, we should be able to create a DynamoDB table. The same way as before, we're going to add a Lambda function. So let me add that. Copy pasting once again. This is the second one. In this case, it's called item process. That's the file name. And inside that, we have the handler that is called handler. I'm setting it to a reserved concurrency of 1. That means that it'll only spin up 1 Lambda at a time for this, since we're going to fetch data from the SQS queue. That's a way of making sure that we don't have multiple Lambdas running at the same time. Setting an environment variable for this as well. In this case, it's for the table name, so that the Lambda function has the property or the variable for the name of our table. Then we're going to have an event to invoke this one as well. And in this case, we want to invoke our Lambda when there are items within the SQS queue. And we do that by setting the event property, and we're setting it to SQS and then referencing the items queue, the one we created before. So once again, an easy way to just reference things that you create within your table. I'm setting the batch size to 10. It means that it will pick up to 10 messages at a time to process. Perhaps my application won't have that much traffic, so we don't have that many messages, but it should still be able to cope with that. So by doing these few lines, we've now set up so our new Lambda function will be invoked when there are messages within the SQS queue. So that's an easy way to use SQS as a trigger. The next part, of course, is to add our code for this. go. And let's just walk through that as well. In this case, we're instead going to use DynamoDB from the SDK, since what we're doing is storing items within DynamoDB. The data from SQS, that's not something we need to handle within our code, how to fetch the data, because that is data that we're getting to our handler in this case, or to our Lambda function through the actual event that invokes the Lambda function. We're getting the data through the event, as I said, and then basically what we're doing is mapping that data so we can go through all of the records that are within it, and then saving it to DynamoDB. So these are fairly basic functions within this Lambda function. But what's important is to be able to handle the data that's coming in and then storing that to DynamoDB. And once again, we're using try catch to do it. So if we're able to store this data, then we get a response back, or the Lambda function has a success back. If not, then it will do an error, and that is logged into CloudWatch in this case. Since we're not using a client for this request, this is something that's happening by having messages in the queue. There's no one to actually watch the result. We don't see the result back in the same way as we did with the previous Lambda. So fairly simple code to be able to store that within our DynamoDB. So what can we be missing? Well, we might be missing some permissions here as well. So let's add those. So this Lambda function instead that needs permissions to be able to store within DynamoDB. Let me see. There we go. And indenting. There we go. What I'm adding to this function is that I'm allowing this function to, in this case, query, scan, get item, put item, and update item. We won't be needing all of those, so let me just remove. We can remove those, I said. Put item and update item. And once again, we're referencing the table that we create in the serverless template. And that should hopefully be it. Going once again.
Yep, by the time it compiles, let's take a quick question. So is it possible to preserve the DynamoDB table if we plan to delete the stack itself?
Yeah, if I, instead of setting the property to delete as I did now, if I instead put it this value to retain, then if I delete the stack, CloudFormation won't delete the table. So it will be preserved. That also means that there will be a table with, if I put a name on it, it will have that name. So I won't be able to add the same stack once again because it can't overwrite the same table. So that's something to remember. But using retain, which should be the default when it's not things you do only for test or dev, that's totally fine. Right, an error. Items table. Oh, my bad. I missed the property on the table. Sorry about that. There we go. It's for the global secondary index that we need to have a projection. What data should be added to that secondary index? Now it should hopefully work. So the first time we create the stack, it takes a bit longer. But on the second time or the next times you do a deploy, it's usually quite quick. CloudFormation is still the bottleneck in deployment to AWS. And it's definitely the same when using serverless framework, for instance, as long as CloudFormation is involved. All right, so let's see how this goes. And if this works, it should create the DynamoDB table. It should create the second Lambda function. And that Lambda function should then see that there is something within the SQS queue, then invoke, and hopefully store within the database if all goes well. So it's still updating the stack. And creating a DynamoDB table might take a while. That's probably it. So in the meantime, let's move over to the queue. There's still a message there. So it's not done yet. We can check. Items rater. So the table is created at least. That's good. Right. So when we've done this, if it works, then we move on to the next step, which is how to retrieve data from this instead. But let's just wait and see so that all works as intended. There we go. And now there is no messages in the queue. That's good. That means that Lambda has picked up our message, but there's nothing within DynamoDB either. So that means that we might have an issue. Let's look at that then. Item process. So this is the function for processing events. What I want to do is look at the logs for that. There might be permission issues, for instance. That's not uncommon. So for each Lambda function, it creates a log group, and that log group is then populated. Ooh, interesting. All right, there we go. We're missing a module that I used in that. So that's good. It means that the rest hopefully was working as intended. In item process, I'm using a module called UUID to create a unique ID for each item. So that's the one we're missing. So let me just first off. Create a package JSON file. Item creator. All right. So then we can do an npm install UUID. Create that. All right. In the wrong folder. Next try. npm install UUID. So now that is created. and then we have to deploy once more. So hopefully that was the only issue that we were missing that. Apparently not. Reinstall the IAM roles per function plugin. All right. So now it's working again. In the meantime, while that is working, let's look at the next step then. So the next step was to create the functionality to be able to retrieve items from the database. And I'm going to do that in two different ways. One way is to be able to retrieve a list of items, and the other one is to retrieve a specific item. They work in more or less the same way, but we're going to create them as two separate ones. Okay, so let's start creating those. We'll have item get.js and item list.js. Those are the two. It's done. So let's try it again so that we know that it works. Create a new item that is saved. There we go. Our items are then, we posted them in Postman. They are sent to the queue, picked up in the queue, and stored in DynamoDB. So that's good. So this is what an item looks like. We have the author, that's me. When it's created, the contents of the item, a unique key, and the number of ratings and the total score for these items. So that's good. Let's continue then creating the get functionality. Item list. An item list, that is, it's probably something that we won't use on the front end of our application in this case, because we're going to do a basic DynamoDB scan of it right now. So this is probably something that we'll use in a different way if this was an actual production application. But we're going to do a scan for right now to be able to list all items in an easy way. So the code for that is pretty basic. We're using the DynamoDB document client from the SDK. Our handler uses an environment that we are going to set in the serverless YAML file, and it's just doing a scan on the entire table to fetch all items and returning that. And in this case, since it's a call through HTTP API, that will then be returned to the client that invokes this request. So that's item list. So let's add it in the template as well. Item list. There we go. The handler called item list. We're referencing the table name as an environment. The event is an HTTP API using a get, and the path for that is /item/list, so that we're able to get an entire list. And what we're missing now is the IAM stuff. And in this case, we don't need put item or update item. Instead, we should hopefully only need scan. So trying to use least privilege as much as possible so that our Lambda functions doesn't have permissions to do more than we want them to. Deploying that. And in this case, the only things it should do is to add an additional Lambda function and a new path in the HTTP API, so that should go fairly quick. But nothing is quick when it's CloudFormation in the backend. So let's just wait a bit. And in the meantime, we can prepare Postman to try that one as well. Okay. Item list and get. So we're able to do a get towards item/list, and hopefully we should receive all items in return then, as soon as this is done. There we go. We can see the new function and we can see the new endpoint. Yeah, so we're receiving JSON with our 2 items. Cool, so that works as well. Next step then was the item get, to be able to get a specific item. And that one is fairly similar, but instead of using scan, we're using a query, of course. So this is that code. Document client. We're setting up the parameters, and our key condition expression in this case is that PK should equal ID. And ID in this case, as we said here in the expression attribute values, is an event path parameter. So we're getting that ID from the path of the request. So we'll look at that later, how that works. But based on that, we're then doing a DynamoDB query instead of a scan to be able to fetch that single item in this case. So storing that. And then in serverless YAML, more of the same. Let's make sure that I use the right one. Item get file name, referencing the table. We're setting up HTTP API as an event using get, and the path is item / and then we have that parameter, the key, the one we're going to use within our Lambda function. There we go, and then we need the parameters, or the permissions once more. In regards to permission, I'd say that that is an area where SAM perhaps is easier to work with, in my opinion, because you're able to reference policy names instead of having this. Well, you have to add both the effect, action, and resource as you do in serverless framework. So that makes it a bit easier. They have pre-created policies instead. So now we need to have query. Should hopefully do it. That looks good. And deploying that. So a bit of deploy time every time we do changes this way.
Yeah, and it's the time that I come in.
Yeah, welcome.
Yeah, so we have a very uh, specific question for you. So it's like, how much time did it take you to know about AWS serverless from beginner to becoming a professional or a
Yeah,
pro?
that's. I'm not sure if I am a pro yet. To be honest, it takes time, but I guess it all depends on what you're building. You can build quite simple things with serverless. You can use few things that are serverless within more traditional infrastructure as well. So that's a hard question to answer, but I've been using serverless for. I'm turning 40 this year, so years go by quickly. But I guess I started using. I think I started using Lambda in 2016. Tried it out in 15, but started using it 2016. So I've been using that for about four and a half years. So, but it doesn't have to take a long time. It all depends on what you're doing, but just getting used to the way you usually work with serverless and with functions, I think that's perhaps the hardest part. Changing your mindset into a serverless way of thinking. That's probably harder than the actual technology behind it, in my opinion.
I think it was the subsequent question again from the same person, from same Rahul. So he says, or at least let us know the time it took for you to get comfortable enough to handle any requirement of the app using AWS serverless.
Yeah, well, I'd say that it's been a few years since I more or less decided that everything we build more or less can be serverless. It all depends on, of course, what you're building and how well where you
It's quite
start off.
subjective. Yeah,
Sorry.
it's quite subjective. It's quite subjective.
Yeah, exactly. So so it all depends on where you start off, but probably easier the younger you are, I guess. When you've
Yeah,
been in the industry for quite some time, you more or less have to know about a lot of old stuff, the traditional ways. So it's easier if you don't know that, I think.
awesome.
Yeah, so
Okay.
now that is deployed as well. So let's try that one also then. Item, and then we need to have an ID. And as we configured before, we need to add that then to the request. And there we go. Now we're able to do a get against this, specifying the ID of an item, and then we get that item in return. So we're getting all the data from that item. So that works as well. That's good. So now we're here. The next step then is to add the functionality for being able to rate an item. And this works in more or less the same way as the other things we've done. So we don't have to go into detail into every step. It's basically the same structure. It just handles data in a bit different way. So let's start off by creating what we need there. We need to have a second queue. Just a second. Need my notes to be able to make sure that I do it correctly. We're adding a second queue. This one we're calling ratings queue. And we might as well create the ratings table straight away. So adding that there. Yeah, and that's a similar setup, a DynamoDB table with some attributes and a schema. We're using pay per request here as well, and the deletion policy is set to delete since this is just for test for me. Right, then we need to add the functions. And we start off with the one for posting a rating. Basic idea is that I'm reading an item and then I'm able to add a rating from 1 to 5, for instance, on that item. So, rating post, referencing a file called rating post. The environment variable in this case is the ratings queue. The event is posting to /rating. And we have the service authorizer to make sure that only people that are logged in and authorized are able to post to that. Then we should add the IAM as well. Let me copy that. Change that to ratings queue, like that. And then we need to create the file, of course. Post. And this is basically the same as item post, since we're not doing anything specifically with the data that is being posted. We're just pushing it into an SQS queue in this case. So more or less no transformation. We're just checking that there is data. That, and then let's straight away create the next one. We have the HTTP API, the Lambda function, the SQS queue. Now we need to have the Lambda function that is processing what is stored within the SQS queue. Rating process. Once again, reserved concurrency to 1. It's only one Lambda function running at a time. Ratings table. This should be invoked when there are items in the ratings queue, and it's fetching a maximum of 10 items per batch. And then we need the IAM permissions there as well. And in this case, the permissions should be to be able to store within DynamoDB. Allowing put and update into ratings table. Right. That should hopefully be enough. I think so. Okay, so deploying that's probably going to take a bit longer since it's creating the DynamoDB table. And I don't think I create the file, so that might be an issue. So let's do that. Hitting process.js. So this is the file that fetches data, the event from the message from the SQS queue, and then stores that in DynamoDB. Without that, it's going to be hard for it to work. And this works in the same way as the item process one. We're just storing it with some different attributes within the DynamoDB table. So that's probably going to fail soon. I'd be surprised if it worked. Yeah. We just have to wait for that to finish. So then when we've deployed, we should be able to then add a rating to a specific item. And then that item or that rating is stored in DynamoDB. Let's see if it finishes. And the next step then after that is having a way of fetching individual ratings. I guess we can create that one while we're waiting for CloudFormation. Why not? And then the last step there is the aggregation of data, where we're fetching data from the ratings table and storing or updating the items table with the actual values. So that's going to be the last one when this is done. All right, so rating get, well, it works in the same fashion as item get. So we're fetching using a get to, that was weird that it worked. Okay. Oh, error message. Oh, strange. So we're fetching it using the key. That is the ID or the key of the item within the database. I can store that now and then create rating get.js. That's an easy one as well. We're setting the key condition expression to PK should be ID, and ID with fetching from the path parameters, and then doing a query using those parameters. What I might be missing is the permissions. All right, and that should be table. Go. I'll deploy that as well. But now we should be able to hopefully send a message to the ratings API instead. And that's this one. We're able to post a message there. We have the authorization in place already. We just need to have the body. And the body for that one should then contain I think it's item, and that should be the ID of an item. Add. And then it should be the rating. And a specific number. We're giving this a 4, for instance. All right. So if I'm posting this now. Hopefully it should create an item within the ratings table containing this rating. So first off, it is saved within the queue. That's a good first step. Then let's see. Ratings table. No, it's empty. Okay, so something didn't work. Let's check the queue first then. Ratings queue. Right, no messages. I guess that's good. And then we need to check the Lambda function to see the one that rating process to see if that picked up the message from the SQS queue. Viewing the logs. Error. Unexpected string in JSON at position 59. All right. Something with my JSON, the one I posted, I guess. Just check. That's weird. Oh, I lost Postman. Let me just try to see what the issue was. That's rating process. Body item. Ah, there we go. Perhaps missing a comma. Let's see if that works. No error this time. So now hopefully, yeah. So now we have an item there. Me missing a comma in the JSON. JSON and YAML, that's always the toughest part. So there we go. So it's created an item with the value of 4. So that's cool. All right. So now we've done this, and I also did this in the meantime. We have one part left, and that's this one, the aggregation of data. So what we want to do here is to have DynamoDB streams active, so that we're streaming data from the ratings table. There we go. Back to the YAML file and to our DynamoDB table. What we're going to add here is configuration for DynamoDB streams, and that's fairly simple. in this case, just adding a stream specification with the stream view type new and old images, so that in the stream that's sent from DynamoDB, it contains both the new data and the old data. There we go. Then we need the new function. Calling that rating aggregator. Once again, a reserved concurrency of 1, so that only one at a time. Referencing the items table in this case, because that's the one we're gonna store data or update data in. We need to set an event here as well. And the event in this case is of the type stream. That means that we're setting a stream as a trigger for this Lambda, and the type is DynamoDB. The other version of that, or the other type, could be Kinesis, so we can have that type of stream as well. But in this case, we're using DynamoDB. Setting up which stream to use, the ratings table, and then we're referencing the stream ARN. So we don't have to hard code which stream it is. That is populated based on the settings or the configuration we have in our template. These are settings for how big batch we might get and how it should start using the stream default settings, I'd say. All right. What we need lastly is permissions. And now we're going to use permissions to, let's see, we need to update items in the items table. Like that. Yes. And then, of course, create the actual file. And I called that rating aggregator, I think. And this one is, it's a bit longer, but it's not that complicated either. This is code that I, in big parts, copied off of James Beswick, a project he did, which had the same type of aggregate functionality. But what it does is that the stream that's coming in as the event, it's going through the stream and aggregating the updates first of. That is, if let's say we have five ratings at a time, it's counting the number of ratings and it's counting the total number of votes or stars or the score. And these might contain both new ratings and updated ratings. That is, Anurag perhaps is rating an item for the first time, while I am changing my rating. The second time I watched the movie, it was only 3 stars. So there is some logic for handling that to make sure that that is updated correctly. And then in the end, what it's doing is it's basically just updating the existing items within the DynamoDB table, and then making sure that the new total and the new number of ratings are correct. So that's what this function does. Storing that. Hopefully I didn't forget anything around that. So that needs to create the stream and so on now, which might take a while. What I'll do in the meantime is delete this rating And these are correct, so that we can check that it updates correctly. Because if I'm posting a rating now to an existing item, it should then first of all be stored in the ratings table, and it should also update the item in the items table. But this stack update might take a little while. So the next step now for us. Yeah,
just a moment. Yeah, just one question. So we have, so if we need to increase the batch size, the question is, if we need to increase the batch size, do we need to update and deploy the code again? It was quite ago, or quite few minutes ago, but yeah,
the batch size for either when processing SQS queues or when the DynamoDB stream. Well, what we do, we update the template file and deploy again. Yes, correct. Because that means that we're still using infrastructure as code correctly. So it will update the stack and then change the configuration instead of doing it, I don't know, using console or CLI.
Yep. And yeah, so quite a lot of people are interested in the code that we are doing here. So I hope we'll be sharing that at the end of the...
Yeah, my thought was that I'll try to clean it up a bit afterwards, and then I'll post it. Perhaps not tonight, but maybe tomorrow.
Yep. So everyone, you can definitely make a point to, you could say, follow Gunnar on LinkedIn as well as Twitter. I think he will post it there, and also we will post it via AWS user group Pune handles.
That's great. All right, so now that one is there as well. Will this work? Item saved. Let's check here first. It's stored in the ratings correctly. And now, if it works, DynamoDB streams should invoke the Lambda function, which should update these items. It didn't work. All right. So now, CloudWatch again. Let's see what it says. Of course. Yeah. Probably the last thing I changed before we started this was to change one of the attributes to the name total, because I thought that made more sense. But instead, that meant that we were unable to update, because you're probably more familiar than me to this, Anurag, but there are a bunch of reserved keywords within DynamoDB. So in this case, we weren't able to do the update. So I guess we can. That's a bummer. It's that one. All right, let's do it like this. Total, let's change it to total points. Let's points. This is how it goes every now and then when developing. Hopefully those are the only places that we're using it. So changing the name from a reserved one to total points instead. And then let's try it once more after this. Hopefully it should work. And the next step after this, when we get this working, is to do some front-end stuff. But once again, my concept of time is a bit off. So let's see how far we get with that.
That's not a problem. We will bear with you. We are enjoying it so far.
You were prepared for that, perhaps.
Maybe.
Yeah. All right, updated. Let's try it again, hopefully this time. Item saved. Item there. Yep, it worked. All right, so now we can see that I posted a rating. It was sent all the way to the DynamoDB table, and the DynamoDB streams invoked the Lambda, the aggregator Lambda function, which then updated the item in the items table so that we can now see that it has 1 rating and it has a total of 4 points. So that's as far as we're going to do with the backend right now, and then move on to the front end stuff. And the front end, well, that's going to be interesting. We're going to start off by using a sample from Auth 0. And, well, let's see how that goes. We're going to applications. We're using the items rater and a quick start. And then we have a few options of how or what stack to use or framework. So let's go with React and download their sample. Download. Okay. Just off screen a bit. Just a second. Items rater. Paste their sample. And call that frontend. That was slow. All right. Then back there. Close the backend folder and open the frontend one. There we go. And I guess to start off, let's install whatever is needed to install. There's probably a lot. So this is a sample from Auth 0. It's really slimmed down, but it contains the bits needed for the authorization, which makes it a bit easier. Instead of creating that ourselves, we can start off with an application that has that in place already for us. And then let's just add some pages as needed for our stuff. And just to make it clear that we're not going to build an application that is ready for production, but we're going to build different parts that make use of what we built on the backend. A bit unpolished, but I hope that's fine. So still installing some dependencies. Let's see. I guess we can start anyway. In the source folder, there is a file for auth config. And it's already populated with my domain. That's good. Then I need to add my API identifier. And that's the one I showed you earlier. This one. So now that should work. Let me close a few tabs. Right. As soon as this is done, we're going to kick off a local development server, so we're able to use the website locally. There are some quite big dependencies. It takes a short while. But first off, we're just going to try to call our APIs to see that we're able to be able to do something with them at least. I know that in the sample there is a page for just checking APIs, so that's the one we're going to use. Okay, now it's done. npm see if it's starting. Loading. That was not quick. Oh well. Guess it takes a while. Okay, looks like it's right now it started. Now there we go. So this is the sample project. Really simple React project. But as I said, it has the authentication built in. So we should basically be able to do login straight away. And then sign in with Google. And yeah. Now I'm logged in. It's fetch data from my Google account. Yeah. So that's good. So now we have authentication in place. And with the authentication, now we're able to do things that require authentication. For instance, posting to our API. We can also see that now when I logged in, it's showing a button that we didn't have before, which is called external API. I think that's, or I know that that's just something that's the external API that it's pinging. That's just another port on my local host. So sure, it works, but it's not that fun. So let's instead try to create something. Let's see if we can figure out how this works. App.js is usually a good one. Here we have the different routes for the page, the profile, and the external API. So that's good. That's one we're going to use. And in the views are the different pages that we're using. So let's start off by let's create a page where we're able to list items. I guess that's a good way to start. So let's making a copy of external API file. And let's call it list items. As you can see in this page, it has a setting for the API. as I said, it was just a different port on my local host. So let's update that with the one that we have. I can fetch it from Postman, perhaps easiest. Copy, paste. And then we had items list, if I remember correctly. And I guess it might be that easy just to get it working, because what it's doing is it's calling an API and just showing the results. So that should be basically the same thing that as we did with Postman earlier. So, but let's just tidy it up a bit. List items. List item from table. List items. And we probably have, yeah, call this something else. List items. There we go. Then let's move to app. Then we need to import it. Forgetting about the hot reload. So every time I'm saving, it's reloading, which perhaps isn't a good thing. List items. This is the root, so the URL will be /list items. List items. Then, of course, we need to add it in the navigation. Might be components. Yes. So this is a component for the navigation bar. And looking at that, when I'm logged in, I can see home and external API. And this is handled through this. So if I'm authenticated, then it's showing this one, external API. Otherwise, I only saw the one that's home. So this is handled using a component from, there we go, use auth0, the auth0 component in this case. So let's just add my list items. And saving. And since it's using hot reload, so it's reloading the daemon every time I'm saving, which means that I have to log in each time. That wouldn't, of course, happen in production. There we go. So now we have a new menu item, list items, and it should work in the same way. If I'm pressing list items, nothing happens. So let's see what happened. What did I forget? Oh, okay. Let me just check. I don't think it's course, actually. I think it's rather me using the wrong URL. But that didn't make a difference. All right. There's probably some other code that I didn't remove. Yeah, here we go. So in the other one, it used some additional code here. One more try. Sign in. Yeah, there we go. So now we're able to list items in our React app. So what we're getting is the basic JSON in return. This perhaps isn't all that good looking in a UI, but based on this, we can then do things with that data. So let's try to tidy it up a bit. Let me see. I'm not going to copy this from another project. So let me just find it. Go. Right. So what I'm going to do is just add some basic code to put this into a table instead, so that it's looping through the data that it's receiving and putting it into a table. So let's see if we're able to do that. Right. Table. Let me just let's put it above that page we got right now. And let's just populate it with the data that we know that we have. We have item, ratings, total points, items, there we go. Item, like that. See if that works on the first attempt. Hot reload. Yeah, more or less. CSS might need some work, but we're getting a table and we're getting the items populated in that table. So the next step, I guess, would be then to if I'm getting a list of items, the next step perhaps is to be able to view an individual item. And we know we've created the function for that because we're able to, we have one get item, I think, or something like that. So just by using the ID, we're able to fetch an individual item. So let's create that one next. And then we need to create a link for it as well. Back here. So let's duplicate that one. Item instead. And that one, if you remember, the URL for that API call was item, and then we had the ID afterwards. So let's add it like this for now. And let's tidy it up a bit. Item, get single item from items table. Get item. Now we don't need that table anymore, so I can remove that one. So first off, let's just try to see that we're able to fetch a single item. So we have that, and we have the API call. I think to be able to, since we're fetching this from the URL, we need to use the React router to do that. I think we can use this one. Importing use params from React router. And that way we're able to get the parameter from the URL. So when we're entering the URL or clicking on a link to go to a specific item, we're able to fetch that parameter from the URL to use that for our API call. So that should hopefully do it. And then we can do let key I think. Now we need to add that key to the API call as well. Yes. So we're fetching the API URL we had at the top, but now with the key added afterwards as well. Might work. Okay, so that's that one. Let's just also add it to the routes so that we have that as a separate one. And this is a syntax I never remember because we need to be able to that. So in our path, it should be /item/ and then the key. That should hopefully work. And then let's add it here as well. Change that correctly. No. Item. Get item. that. All right. So this one isn't needed to be added to the navigation bar, since we don't have a link to a specific item. That's going to be from the list of items instead. So I won't be adding it there. But in the list of items, now we want to create a link as well, so that we're able to click on our items to get to that page. So link should be item and then the ID. Then we need to use the React form for links. That's link to this is add. Not using that. Might work. Link is not defined. All right, we need to import that library as well, and that's also from warnings. List items. It is a link, and the link looks like I want it to. So I'm sent to a new URL, and I can press get item and get that specific item. So that's pretty good. That means we're able to view all items, and we're able to get the specific items as well. Next then, well, perhaps be able to create a new item. Create a simple form for adding items. So let's do that. Let's see, I need to go back here. And I suppose we can do that by, let's reuse get item for that. Add item. Add item. And this should perhaps be in the navigation bar as well. So let's add it there soon. And navigation bar. Can reuse that one. Add item. There we go. And then to change this one, and when we're posting an item, that was this same URL, so /item, but instead we used a post. So need to figure out how to change that. I guess that's call API. Yeah, so this is the function for calling the API. We're removing the key now, but instead we need to add that instead of a get, we should use a post. I guess. What else? Yeah, we need to add the body of our post should be JSON from our form. Yeah. So let's create the form then. It's also something I think I can reuse. Tidy a bit first. The only value we're actually adding is this, the one that's called item. But perhaps we need to create item form. Oops. Form data, yeah. And then we have the form, and then we need to define form data. So that seems about right. We can use this for that. Item form, and we're getting it by the ID of the element, and the form name was item form, and then form data. That should hopefully work. No. Add item. Right. Forgot to remove that one. Copy-pasting. And I forgot to remove that one. Okay, so let's see how this goes. So now we have add. That was strange. My bad. Event. Logging in. Add item. Well, it is a form. We have one field. Okay. Didn't seem to work. All right. The attribute value for a key attribute cannot contain an empty string value. So let's see what I did wrong. Item, this is an item. So for some reason that isn't working. Why isn't that working? Right. Oh, maybe I should add window. There. There we go. That's right window. Add item. Let's try it again. There we go. A small error in the URL. What's the thing? All right. So now I'm able to save an item as well. And that should then hopefully kick off the entire thing here. So it's stored in SQS and then picked up and stored into DynamoDB. So let's check that by trying to list items. Yeah, so now we have three items instead of just two. So that works as well. Yeah, I'm not sure. Maybe that is as far as we're going to take this application right now. What do you say, Anurag?
It's all up to you.
Yeah.
If you have the energy.
I think we've covered most. Well, we haven't added anything for rating. Perhaps we should do that.
It's not going to be any different than what we have done.
Not really. It works more or less in the same way. And this is really unpolished. But what I want to show is that it's fairly easy to use the things that you've created using serverless in a front-end application. I just started off with a basic template from Auth0 just to get the authentication. If you're not in need of authentication, well, then you can start off with a simple sample directly from React or one of the basic samples there and do the same things. And beyond this, well, it's fairly easy just to keep doing the same things, but perhaps in a more user-friendly way. But hopefully it showed a bit about how you can do. So looking at the entire application, This now we can deploy, of course, to Amplify Console, for instance, to have that as a single page application there. And then we have the backend, which is entirely serverless. And having that, well, it means that this application could scale more or less limitless, I'd say. We should be able to have as many items as possible pushed into the application. We could have as many users as there are available to use the application and rate items and so on. If we want to continue with this, build it perhaps even more robust and reliable, well, then we add things for handling failures if there are failures. For instance, Lambda destinations on the processing ones, on the aggregation Lambda. We can have dead letter queues and so on. And then when it comes to the data that we're showing on the front end, not use a scan for showing the entire list. Of course, we're doing that by querying and definitely adding different types of caching, perhaps adding GraphQL using AppSync as a way of fetching the data instead, and all of the benefits we get by using AppSync and Amplify CLI as well. So there are a lot of things we can do based on this, but hopefully it shows a bit about how easy it is to actually build a semi-large application that contains a lot of bits and pieces. But all in all, the template file for this, it's not that big. Most parts of it is actually IAM stuff. Strip off that and the template file is half as big.
Yeah, absolutely. I mean, look what we built in a couple of hours. It's just ridiculous that we are talking about front end to middleware to all the processing with all the APIs authentication done within 2 hours. Definitely, it can be polished more, but it does give us a complete glimpse of how an end-to-end application in serverless would look like.
And one of the real benefits with using serverless is that this is an application that's now it's just test dev stuff, but we could more or less take this into production today, and it would be able to handle all of that load. If you're used to building in a non-serverless way, well, your test or dev environment is probably far from the environment that you'll be using in prod later on. And just spinning up the prod environment is probably related to a lot of cost. In this case, this isn't going to cost me a cent unless usage goes up, but I'm quite sure it won't on this application.
Yep, makes sense. Excellent. I hope people got a lot of value from this particular session, and I genuinely would like to thank Gunnar for taking out a lot of time from his busy schedule and agreeing to speak to us, address us at AWS UG Pune. If you're not aware, Gunnar regularly speaks at a lot of events throughout the world, and the pandemic fortunately has given him a way to speak at a lot of geographies while sitting at his home. So you should definitely connect with him on LinkedIn, on Twitter, and if you have any more questions, I'm hoping Gunnar will be more than happy to address it if you just DM him the queries.
Oh yeah, definitely. I want everyone to use serverless, so if I can help in any way, just get in touch. And as I said initially, the repository for this, well, I'll clean it up a bit, and then I'll put it in a public repository, and I'll share the link for you. And then perhaps parts of this is something you can use in your own applications going forward.
Yep, we have given the skeleton. It's up to you to make the body complete.
Yeah.
Awesome. Thank you everyone who have joined. Thank you, Gunnar, for taking out a lot of time. So speaking for more than 2 hours. 2 hours 20 minutes. It's not a joke. uh, I hope you enjoy the rest of the day. Good evening, good night to everyone in India, and Gunnar, have a nice day rest of the evening.
Thank you all.
Bye bye.